On page 744, the last section of chapter 10, equations of circles. And we have two learning targets. Write the equation of a circle, and then we're going to use the equation of a circle. Now, since all points on a circle are equidistant from the center, you can find an equation of the circle. And I'm not willing at this point to go into just how we come up with that equation. But I want you to realize what an equation is and or does. Okay? In algebra class, if we graphed a line, we would say, hey, what that means is that every point on that line, if you put its x-coordinate in for x in the equation and the y-coordinate in for y in the equation, you got a true statement. In fact, that's how you came up with the points, right? Remember, you made a little XY chart, you'd choose x, figure out what y had to equal to make it all work out. So that's what an equation is. That's how an equation relates to a graph, okay? The points on the graph, their coordinates make the equation true. Well, the same thing works with a circle, okay? Whatever the coordinates of that particular point are right there, it's going to have an x-coordinate, it's going to have a y-coordinate. If you put the x-coordinate in for x and the y-coordinate in for y in the equation of the circle, it'll make a true statement. And if you want to find those points, you can make a little XY chart, just like you did when you were doing lines. Now, you'll need a lot more points. Otherwise, you won't see what the circle looks like. Instead of choosing 2 or 3 points, you'd probably need 8 or 10 to know for sure that it's a circle and then how it looks and all that. But the point being, any point on the circle, when you put its x-coordinate in for x and its y-coordinate in for y into the equation of the circle, it makes a true statement. In other words, the coordinates of those points are solutions to the equation of the circle. The coordinates of the points are solutions to the equation of the circle. Now, fortunately for us, circles have easy equations. They look complicated at first, but after we've worked with a couple of them, they're fairly easy to work with. Not quite as easy as lines, but they're pretty easy to work with. Okay? So, here is standard form for an equation of a circle. If the center of the circle is called HK and the radius is called R, then the standard form for an equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. And I'll grant you it looks intimidating at first because it's got not only x and a y, which you probably expected. I mean, lines had x's and y's. But it's also got an h, a k, and an r. But it's okay. These are things that come with circles. You're going to know what the center of the circle is. Okay? And you're going to know the radius. If you don't know them, they're going to be relatively easy to find. Okay? So h stands for the x-coordinate of the center. K represents the y-coordinate of the center. R is radius. So that is the x-coordinate. So h is the x-coordinate of the center. K is the y-coordinate of the center. And R is the radius. You probably could guess R. So that's what everything stands for. And that's called standard form. It says it's also called the center radius form. I've never heard that in my life except for right then. That's the first time I've ever said it. So it's called standard form for an equation of a circle. All right, let's see if we can use it. So we're going to write equations. So turn to page 746. Now let's get started on your assignment. So for number one, the center is at 9, 0, and the radius is 5. So all we've got to do is fill it in to our standard form. X minus, and then H represents the x-coordinate of the center. What's the x-coordinate of the center? So we put in 9 for H, quantity squared, plus y minus 0, K stands for the y-coordinate of the center, 0 squared, equals 5 squared. Okay? Only thing left to do is a little bit of simplifying, but leave it in standard form. So in other words, don't try to square that x minus 9. Don't do that. Leave it as x minus 9, quantity squared. But I can simplify the next parentheses because y minus 0 is just y. So I can just put y squared equals, and I can simplify 5 squared, 25. Because if I square that x minus 9, then it's no longer in this standard form. Okay? There's nothing wrong. I mean, there are other forms of the equation, but all we're going to learn standard form, so leave it as x minus 9, quantity squared.
Why does it not find it next?
Yeah, isn't that the weird thing? With a line, to be able to get the line or to get the equation or to draw the graph, you had to know points on the line. With the circle, you don't. You have to know the center, and you have to know the radius. Now, what we could do now is we could find points on the circle. We'd make a little XY, which we're not going to have to do, but I just want you to understand. We'd make a little XY chart. We'd pick an X, like, you know, and it gets iffy because on a circle, you know, if that's the axis, not every point in the world is on that circle. Like a line, you could pick any X and it would work. So you have to be, you know, fairly good guesser, you know what I'm saying? So we could pick like 10, we'd say, okay, 10 minus 9, that'd be 1, plus y squared equals 25. So y squared would be 25 minus 1, 24. So y would be the square root of 24. And that's a point then on the circle. Okay? So that's why I said the equation is kind of easy to work with, in that you don't have to know points on the circle. All you have to know are the center and the radius. And what's the most common thing to know about the circle? The center. And what do we almost always know about a circle? Its radius. Okay? All right, let's try number 2. So, x minus, what do I put in for h? 3, because that's the x-coordinate of the center, plus y minus, what do I put in for k? 1, because that's the y-coordinate of the center, quantity squared, equals, be careful, they told us the diameter. If the diameter is 14, what's the radius? So 7 squared, not 14 squared. Well, I'm really happy with that. All I want to do is write 7. I want to write 49 instead of 7 squared. If there's nothing to simplify these, then don't mess with them. Leave it in that form. That is our answer. That is our equation. So, like we did on number 1, we can find points on the circle using that equation. It's a bit cumbersome, okay? And you do a lot of bad guessing. Like if I guessed x equals 100, I'm not going to get anything. That point's not going to be on that circle. With a line, you didn't have to worry about that because all the x coordinates were on the line somewhere. But with circles, you can you can do a bad job guessing. That's why it takes more points to figure out what the circle looks like. But look, well, I'll get to that in a second. What I'm going to tell you is by knowing the equation, graphing that's pretty easy, isn't it? You know where the radius is, or you know where the center is, you know how big the radius is, and you're done. All right. Now, number 3. The center is at the origin. What are the coordinates of the origin? 0, 0. So for number 3, we would have x minus 0 quantity squared plus y minus 0 quantity squared equals, and it passes through the point 2, 2. So they didn't tell me the radius. That's okay. Because if I've got 0, 0 for the center, and it passes through the point, the circle passes through the point 2, 2, that means the point 2, 2 is on the circle. Doesn't the radius connect the center to a point on the circle? So I can find the radius just by using the distance formula. Make sense? They don't tell me the radius, but the radius is a segment that connects the center to a point on the circle. So find the distance from the center to that point on the circle, and that's the radius. So radius equals square root of 2 minus 0 quantity squared plus 2 minus 0 quantity squared. Well, 2 squared is 4. So the square root of 8. So r equals the square root of 8. So on the right side of my equation, radius square root of 8 squared. Now, I can simplify that equation some. Instead of x minus 0, how about just x squared? Plus, instead of y minus 0, let's just go with y squared. And instead of the square root of 8 squared, what is the square root of 8 squared? And there's my equation. We okay with 3? All right, number 4. The center is at negative 5, 3. So x minus what? Yeah, x minus negative 5 squared plus y minus 3 quantity squared equals, and then once again they didn't tell us the radius. That's okay. I can find the radius using the distance formula. So find the distance from the center to a point on the circle. So find the distance from that point to that point. So that'd be 1 minus negative 5 quantity squared plus negative 4 minus 3 quantity squared. So 1 minus negative 5, that's 1 plus 5, that's 6. 6 squared is 36. Plus negative 4 minus 3 is negative 7. Square the negative 7. We get 49. Put the square root of, and then what's 36 plus 49? And we've got the radius. So back to my equation. For r, I put the square root of 85, and then I got to square it. Now, I can definitely simplify this equation. So instead of x minus negative 5, I'd rather write x plus 5 quantity squared plus y minus 3, I'm good with, quantity squared, equals 85. Okay? We okay with those? Number 5. This time, instead of giving us information in a sentence, they've drawn us a graph. So for number 5, to get our equation, x minus, what's the x-coordinate of the center of this circle? 2 quantity squared plus y minus 1 quantity squared equals, now, I don't even have to use the distance formula for the radius this time. The radius goes from the center to a point on the circle, so doesn't that segment right there represent the radius? Since I made it horizontal, I could just count spaces. What's the length of the radius? Squared. The only thing I want to simplify is the 2 squared. So x minus 2 quantity squared plus y minus 1 quantity squared equals 4. We okay with 5? All right, go ahead and do 6. See what you come up with. Confident on the radius? I'm not. I can draw in some, but I'm not sure how many spaces that is. It's more than 3 and less than 4. Is it 3.5? Maybe it's 3.49. It was 3.4. So, darn it, I guess we're going to have to do the distance formula. I was hoping to not have to, but radius equals square root of, we can do 0 minus 3 quantity squared plus negative 6 minus negative 4 quantity squared. All right, 0 minus 3, that would be negative 3, square that, get a 9. Negative 6 plus 4 would be a negative 2. Square the negative 2 and get a 4. So we get a square root of 13. Wouldn't have really guessed that. So square root of 13 squared. All right, does everybody have what I have so far? And let's simplify that. Let's leave that as x minus 3 quantity squared. Let's change that one to y plus 4 quantity squared. And then the square root of 13 squared is 13. Now, notice something here for me. Notice that when the coordinate of the center is positive, x minus that, you have a negative sign showing up there because it's x minus whatever or y minus whatever. Then look what happens here. When the coordinate of the center, in this case the y coordinate of the center is a negative, since you're going to do y minus negative 4, when it shows up at the end, it shows up as a positive 4, doesn't it? And we should be familiar with that from the distance formula and slope formula and whatnot. You know, minus a negative is a positive. Okay? All right, you guys hanging in there? You still with me? Getting it? All right, now we're going to use the equation. So for number 7, for each circle with the given equation, state the coordinates of the center and the measure of the radius, then graph the equation. All we need to graph this circle is the center and its radius. And we can get that right from the equation. From this equation, I can tell that the x-coordinate of the center is 3. How can I tell that? Because it's x minus h quantity squared. So the h has to be 3, doesn't it? And from the equation, I can tell that the y-coordinate of the center is -2. Because isn't that supposed to be y minus k? Well, so it's not positive 2, it's not y minus 2. That would have to be thought of as y minus -2, wouldn't it? You following me? Okay. Now, what's r have to be? 4. Because that's r squared. So doesn't that mean r is the square root of that? Which is 4. So I'm just doing the same thing I did to get the equation. I'm doing the opposite of it. I said the same thing. I'm not doing the same thing. I'm doing the opposite of it. Okay? From the equation, I'm extracting the coordinates of the center and the radius. Does that make sense to you? Well, then here's how you draw the graph. And your graphs can be unattractive. That's fine. Mine will be. The center is 3, -2. So 1, 2, 3. So that's the center. Now, a radius of 4. All I'm going to do is count 4 to the right. That's a point on the circle. From the center, 4 down. That's a point on the circle. From the center, 4 to the left. That's on the circle. And from the center, 4 to the right. And then watch how bad my circle is. And that's fine. Try to avoid making them look like squares. But if it's a rounded off square, I'll take it. Okay? So that's all you got to do. Number 7 makes sense? Let's see what we can do with 8. What are the coordinates of the center? 0, -1. It's x minus nothing, so it's x minus 0. And then that's not y minus 1. That would have to be y minus -1. With me? What's the radius? 2, because that's r squared. So if r squared is 4, r is the square root of 4, which is 2. Right, draw you a graph. Wow, that's pretty bad. I even missed one of my points completely. But I'll take it. Questions on equations of circles. All right, here's your assignment.